A few years back, phrase like VPN ban was something that you would only hear in a highly censored country like China, Russia, or Iran. But today it's a talking point of politicians in democratic countries. What we are seeing today is an unprecedented attack on the privacy of the internet users.
This video is quite long, and still it only gives a brief overview of censorship circumvention technologies. I recommend everyone to watch it full, but if you are here just for the practical instructions, in the description there is a timecode to jump right to the part where I show how to set up a proxy that is invisible for the censors. For your convenience, I also added a text version of the manual so that you could copy-paste commands. Hit a like button and subscribe to my channel. YouTube loves it, and I would greatly appreciate you doing this. After the notorious UK Online Safety Act kicked in, enforcing mandatory age verification on the platforms with content that authorities deemed age inappropriate in UK, there was a surge of VPN usage, which in turn led to tightening the laws and imposing fines on VPN services that used phrasing like age restrictions bypass in their ads. And though it didn't result in a blanket ban, it's a first step and a dangerous precedent that didn't come unnoticed by other legislators who want to limit free access to information in the World Wide Web. Apparently, some Republican lawmakers from the state of Michigan in the US got so inspired that they drew up their own version, Anti-Corruption of Public Morals Act, which would not age restrict but outright ban some types of adult content. And just to be sure that people comply, the bill also proposes a ban on VPN and proxy usage. As of September 2025, the bill has not yet passed, and there are doubts that it ever will. But these signs of gradual shift from free access to information to a highly censored internet are a grim sight indeed. Authors of such initiatives usually sugarcoat their proposals using classic narrative of protecting the children. But sad truth is that once tools of oppression are created and tested on some types of content, we are one step from those tools being used to oppress free speech, censor the media, and even block the means of communications that we rely on. In Russia, 15 years ago, internet was global and unrestricted. And it all started with their own protect the children narrative. Today, a lot of platforms, including YouTube, are inaccessible without sophisticated VPNs or proxies in Russia, and people can't even use voice calls in messengers like WhatsApp, Signal, or even Google Meet, because ISPs would just block any voice traffic if they detected, all to make people use either surveillable cell carrier calls or a newly released state-owned messenger app. The goal of this video is to give people from countries with no internet censorship an overview on how censorships are bypassed by people who face restrictions, and also to show how far people would go to access the free network, and to demonstrate how talented developers and engineers who believe in freedom of information usually beat censors on their own field. We will start with an overview of basic widely known measures of bypassing censorship that were historically used, and then move to the most sophisticated tools that are available right now. Proxy is a server that relays someone's network traffic to the destination, as if this traffic was its own. It's a very old concept from the early years of internet, and it's still viable and widely used. HTTP or HTTPS proxies, as their name suggests, proxy HTTP or HTTPS requests. It's a type of request that your browser sends to the server when you want to access a website, or your mobile app sends to the content server to show you fresh content. This is useful when you want to hide your real IP address from the website that you're accessing, but it's useless against censorship on the ISP level, because a proxy like that does not conceal, encrypt, or obfuscate data in the HTTP headers, and it clearly indicates which website you are trying to access. But usually it won't even come to that, because censorship initially happens on the DNS level. ISP detects a DNS request to blacklisted website and responds with its own IP address that shows you a restriction banner and thus prevents you from accessing a website. Next basic level proxy protocol is SOCKS 5. It's more universal than HTTP or HTTPS proxies because it can proxy any type of request or traffic. but it also lacks any intrinsic encryption or obfuscation. Thus, it is transparent to the ISP in the same way. Proxies like that were used to bypass censorship on the very early stages of its development, when it was done using IP filtering based on black or white lists. Back then, there were no technologies or computing powers to do sophisticated packet analysis on the fly in scales that would cover ISP mainstream traffic. VPN stands for a Virtual Private Network. It's a technology that was developed to solve a non-trivial task. Organizations need to have private local networks that would connect their assets in different locations into one single local network. On the physical level, such network inherently has to rely on Tier 1 and Tier 2 internet service providers who own the cables. But here's the catch. If your traffic goes from Dallas to New York, it passes a lot of routers and public network nodes, and anyone with access to them would be able to spy on the data that they transmit. Back then, HTTPS was not even conceptualized, and all network traffic was transparent. So there came solutions like OpenVPN that would create an encrypted tunnel with its own network topology over the public networks. For that purpose, a number of solutions were developed, to name some. Already mentioned and most popular OpenVPN in 2001. AnyConnect released by Cisco in year 2000. IKE v2 IPsec that was rolled out by Microsoft in 2005. Later, a next generation of more efficient VPNs emerged. SoftEther, OpenConnect based on AnyConnect, and WireGuard, which is widely used right now due to its speed, lean code base, and integration into Linux kernel. But when I say next generation and increased efficiency, I mean their speed and code base optimization, not censorship resistance. For a long time, these VPNs were an ultimate solution to bypass any censorship, because they prevent ISP from being able to see the traffic user sends and receives. And if DNS queries are also sent over the VPN, there's nothing censors can do. Of course, they can always ban and block VPNs, which China, Russia, and Iran did. But it's one thing to ban something, and whole other story to be able to enforce the ban. But technologies evolved, computing powers grew, and at some point, DPI, statistical traffic analysis, and VPN IP monitoring became a reality. Right now, traffic inspection technologies allow to detect and surgically deteriorate VPN connection speeds without affecting any other non-blacklisted traffic. Tor holds a special place due to its unique technology and lineage. Of course, it's always fun to know that it was developed by US military and soon after stolen and made publicly available by hackers. But it's not a VPN and it's not a mere proxy. It's a sophisticated set of proxies, a browser, and node software that applies a multi-layer encryption that was supposed to be anonymous by design. But actually, its design has some flaws. For example, nodes' IPs are publicly known, so censors can monitor and blacklist them, which they do. Tor team responded by implementing Bridge and Snowflake technologies. Bridges allow to use yet another proxy unknown to censors in order to access the guard nodes, and Snowflake enables users from uncensored locations to allow other Tor users to use their devices as a relay. So, as a way to bypass censorship, Tor core technology is not very efficient. It relies on additional obfuscated proxies, which themselves would be enough to bypass censorship, even without using Tor network. When it became clear that regular VPN efficiency as a measure to bypass censorship is dropping fast because of VPN detection technologies, a few development teams came up with their own solutions. Most popular and widely used is Amnesia WG. It's a fork of WireGuard that features a set of measures that obfuscate UDP datagrams that WireGuard uses, so that they would not look like your typical WireGuard traffic. It of course requires specific server and client software, and it demands a more sophisticated setup than your normal WireGuard. But still, Amnesia is a promising project, and some VPN as a service providers already offer Amnesia WG configurations along with classic WireGuard. Another one is OpenConnect. It's an open source fork of Cisco AnyConnect, and it features a camouflage directive added to its config. It allows to mimic VPN traffic to look like a regular HTTPS. Downside to that is that you need to have a domain name for OpenConnect to work. even without the camouflage enabled. And also, because of its predecessor's age, setup is tedious and configuration file is bulky. Add to that a lack of user-friendly client apps, and it becomes a Plan C solution at best. And now we finally come to what appears to be a pinnacle of anti-censorship technology available today: stealthy proxies. Mostly they emerged as a pushback against ever-evolving Great Firewall of China. VPN usage is illegal there for a long time now. So before stealthy VPNs were even created, people needed to jump the wall, as they call it, and not get caught by police. So it wouldn't be practical to base a solution on some existing VPN technology. Besides, a lot of features of VPN you just don't need if all you want is to use Google from country where access to it is blocked. Thus emerged shadow SOCs, a universal proxy just like SOCS 5, but with added layer of encryption and obfuscation. It would make network traffic look like total junk. Thus, network filters that at the time used a blacklist approach to detect and block traffic that has a signature of regular VPN or proxy would fail. Predictably, it made censors to switch to whitelist model. If it's a regular HTTPS or other generally allowed type of traffic like QUIC, they let it pass. If it's something else, whatever it is, just block it. In parallel to shadow SOCs, there were two promising protocols in development: Hysteria and VMESS. Their developers chose not to make their traffic so different it would not be treated as VPN, but to make it look like HTTPS or QUIC traffic so efficiently that it would be indistinguishable and thus would bypass all attempts to detect or censor it. And for now, they succeeded. Both protocols evolved, and right now it's Hysteria 2 and VLESS with XTLS reality obfuscation flow. Hysteria 2 shows promising results, and its crown feature is how stable it is on weak internet connections. Developers came up with aggressive loss prevention technology that allows users to have decent connection quality even if the speed is generally low. Mostly, it obfuscates traffic to look like QUIC, a modern protocol that sits on top of UDP and is widely used for streaming. For example, right now this video is streamed to your device by YouTube using QUIC. VLESS uses XTLS, an innovative technology that allows it to mimic traffic that is designated for any other website that uses TLS version 1.3, which most modern websites use. When set up properly, it initiates a handshake with some uncensored website, and later would use it to mask the traffic between your device and the proxy server. So if you use yahoo.com as a decoy, and you go to YouTube, Google, or Wikipedia, your ISP would see all that traffic as a traffic to Yahoo. Right now, many VPNs as a service that target users from censored locations also offer VLESS or Hysteria 2 configurations. Technically, it's not a VPN, but for commoners in censored countries, VPN equals censorship bypass. So they sorta hijacked the acronym. Also, there are a few projects like Hitify and 3xUI that allow users with basic Linux skills to set up their own servers and distribute and even sell subscriptions to their proxy services. In the final part of this video, I will demonstrate you how anyone can create and use their own stealth proxy using VLESS with XTLS reality flow. We will be using 3xUI. Since we are about to set up our own proxy server, it's quite essential to have a server. One of the easiest ways to get one is to go to digitalocean.com, create an account if you don't have an account there, and then proceed to create a droplet. That's how they call virtual servers here. Choose any location that suits you. For OS, leave it at Ubuntu 24 LTS version, and choose the cheapest option possible. Then you need to choose authentication method. I will be using SSH key for authentication. If you don't have an SSH key, if you don't know how to create and manage SSH keys, just switch to password authentication here. After I hit create, I just need to wait until IP address shows right here. IP address is shown, which means that VPS is created and ready to use, and I can proceed to creating and setting up a proxy. Now that I have a VPS, First thing to do is to SSH into it. In order to connect to the server, I'm going to use Linux terminal. If you're on different operating system, for Windows you can use PowerShell, and for macOS you also use the terminal. The command is going to be exactly the same. When you connect to a server first time, you need to say yes to this question. And as always, it's recommended for when you connect to the server for a first time, update repositories and update the software on the server. If you see a question like that, just hit tab and OK, keep the local version. Unless, of course, you know which option you need and you know exactly what you are doing. If you don't want to end up with a broken server, that is. After the update process is complete, we can proceed to installing 3x UI. The link to this GitHub repository is going to be in the description, and installation is quite simple. You just copy this line, paste it into your terminal and hit enter. Now, what it is going to do, it is going to use curl to download whatever is at this link, which is install.sh script, and it is going to pass its contents to bash. And bash will run the commands and set everything up for you. When you are prompted a question like that, I suppose you say no. Bear in mind that when it asks us to set up some specific port or a random port will be applied, it's not a port for your proxy. It's a port for the URL that you are going to use to access a web panel. And a small problem that I have with this script as of now is that for whatever reason, it uses HTTP, which means that if I am to connect to my proxy web panel using HTTP, I will expose to my ISP and to whatever network nodes my traffic passes through everything: username, password, and the web-based path, which are supposed to be secret. So first thing I'm going to do is I'm going to copy all of that and save it. And I suggest you do the same, because this is exactly first and only time you are going to be shown these parameters, because even through the menu, you cannot see username and password. You can only reset them. Once it is done, it's a good thing to set up a self-signed SSL certificate. And to do that, I have this little script created, and you run it like this. Of course, you can log into your web panel and you can manually set your SSL certificate there, or you can create it manually and assign it using the XUI menu. But it's a nuisance and my script automates it. So after that is done and I see that SQL inserts were executed, and those SQL inserts are basically passed to the certificate and the private key, because XUI uses a database to store all that stuff. I need to go to the menu and I need to restart the panel. And now an important part. Ask it to show me the settings. Right now we can see that panel is secure with SSL, finally. And the access URL now uses HTTPS as opposed to HTTP that we had here. And now I can copy the panel URL, paste it into the browser, hit advanced, and here accept, risk, and continue. Before I do that, why am I seeing this warning? I'm seeing this warning because I'm using a self-signed certificate, which means that no certificate authorities like Let's Encrypt or Komodo or Google or whatever has verified this particular SSL certificate. And usually if you're accessing someone else's website and you see something like this, then it looks fishy. But in this case, it's okay because we created our own SSL certificate to encrypt the connection ourselves. And now use username and password to access the panel. And now, in order to create a proxy connection, we need to go to inbounds and add an inbound. Protocol I leave at VLESS. Port, and this is important, we need to set up as 443. That's the default HTTPS port. Because if you are in a censored location, there is a high possibility that a pattern of HTTPS traffic going to non-standard port, not to 443, is going to get flagged and can get your server IP blacklisted, which would result in you not being able to connect to your proxy. So use 443. This part will create a client configuration, a singular client configuration for someone to connect to the proxy, which is okay. And for security, you need to choose reality. UTLS we leave at Chrome. Chrome is the most popular browser. And this setting, it basically says that the traffic between your device that is using proxy and this proxy server will be looking like a traffic from Google Chrome browser to a website. Next part is setting a decoy website. If Google is not censored in your location, Google is just fine. But if, for example, Google is blocked, you can choose something else. You can choose Yahoo, and that's exactly what I'm going to use. Next important part is you need to click this button, Get New Cert, and then hit Create. And that's it. Now we have a proxy configuration running on our server. And the next part will be to use some client to connect to that proxy and to check that it is actually working. One small thing that we need to do before the setup is finished. Click this small plus button and set the flow to XTLS or PRX Vision and save changes. For the purpose of this demonstration, I will be using Windows machine, and I will show you how we can set up Necobox app to connect to our proxy. The process is going to be the same for Windows and for Linux machine, because there is also a release of Necobox for Linux. For Mac OS, I suggest you use Foxray. And regarding the Android and iOS platforms, we will get to that a bit later. Some warning before we start. Up until recently, one of the most convenient and shiny clients for stealthy proxies was Hittify. And I'm going to show you why I say was, not is, just in a moment. First time when I downloaded Hittify application for the purpose of filming this demonstration, Windows Defender killed it. And I was like, what the hell? Then I decided to check, and yeah, it would appear that there is some malware in Hittify Windows installation archive. And I honestly don't know if there is a malware also in Android or iOS version, but just as a precaution, I would stay clear of Hittify at least for some time. Maybe just use some different app. That's why I'm using Necobox right now. So to download Necobox, go to getnecobox.com or just follow the link in the description. Find this link. And we need to download the zip archive for Windows. I already have it, and I already have it extracted. There is no installation process, just a standalone file. So you just double click Necobox and it launches. Now, in order to add our proxy configuration to the app, we need to go to our web panel, hit plus button here, click I on more information, and here copy this URL. And in Necobox, click server, add profile from clipboard. You can click URL test to check if it's working. And yeah, if you see ping here, it means that it works fine. Right click, hit start, and that's it. The proxy is working right now and it's waiting for connections, but still the traffic is not sent through the proxy. Here we can see that IP address is clearly not in Germany, it's in Sweden. So if I want to funnel all the traffic from all the apps that can use proxy setting, I just tick this box system proxy. And if we check it again, you would see that my IP address now is in Germany. There is also what is called a tune mode. Tune mode would require to restart Necobox and launch it with administrative privileges, but it would create a tune interface just like your normal VPN would do, and it would use the routing rules in order to send all the system traffic through this tunnel interface. But just for using the browser, system proxy setting is quite sufficient. On Android and on iOS, there is a number of clients, and you can see right now the list of those clients. And connecting from Android or iOS is actually even simpler. In order to connect to the proxy using any mobile app, you just need to scan the rightmost QR code. When you scan it, it would automatically add a configuration to your proxy application. And usually it's a single button setup. You just click it and it connects you to the proxy server.